7 of 100 days of Solidity series. So in this video we will see operators in Solidity. Okay, so there are 4 kinds of operator which we can use in Solidity, those being arithmetic, comparison, logical and bitwise. Okay, so let's see one by one. First being arithmetic operator. Okay, so the first one is addition operator. As you all might know, it's the plus sign. The second being subtraction, like if you want to add two things, like add two numbers, you will do 1 plus 2, and if you want to subtract any two numbers, you will do 1 minus 2. And the third one is multiplication operator, which is 1 into 2 if you want to multiply two numbers. And the fourth operator is division operator. One thing you should notice is that Solidity variables are not designed to hold decimal numbers. Okay, so if you do 5 divided by 1, it will be 2, not 5. Actually 5 divided by 2, it will be 2 instead of 2.5. Okay, so why is that? Because it can't hold decimal numbers. Okay, it only holds the integer places of those division result. Okay, and the fifth one is a modulus operator, which is used to get the remainder of a division. Okay, so if you do 5 divided by 2, the remainder will be 1. So if you want to get that like that, you can use the modulus operator. Okay, so the final sixth operator of arithmetic is power operator. Like it's a, if you want to do 2 power 3, what you would do is you would do 2 doubles are 3. Okay, so this is how you would do it. Okay, I guess it's 8. Yeah, fine. Yeah, so these are all the arithmetic operators in Solidity. Now let's see comparison operators in Solidity. Okay, so there are a couple of operators in comparisons. So the first being equals. Okay, so if you want to compare two numbers, actually if both are equal, not only numbers, you can compare strings as well, but for now, if you want to compare, let's say two numbers, if let's say 2 equals 2, if you want to compare that, if you want to know 2 equals 2, what you would do is 2 double equals 2. This is for the equals which you can use to compare two numbers. And if you want to know whether they are not equal, you do like this, not and equal. If 2 not equal to 2, if you want to check like that and assign it to a variable. And this is a greater than symbol, like all these return the value either true or false. Okay, one thing to notice. And if you want to compare two number, like whether number A is greater than number B, you would use the greater than sign. In another case, you would use the less than sign to check if the number is less than another number. And if you want to do like greater than or equal to, you would do like this, and less than or equal to, you will do like this. Okay, so these are all the comparison operators. Like again, I believe like there is no much examples needed for this, as you all can easily understand the way they work. Okay, so these are basic ones, and we will see like examples for bitwise. Okay, and let's go for logical operators. Okay, so let's say you want to combine two conditions or any two numbers and make them one. It's not actually working here, but here in this case we will combine two boolean values. Okay, so the first one being logical AND operator, what it basically means that if both left hand side and right hand side are true, it will return true to the assigned variable, and if any of one is false, it will return false. Okay, it will be resulted in false. So this is AND operator. If any of one is false, it is false. If all are true, it's true. Okay, so OR. So this is logical OR operator. What it basically means is if any one of the logical OR operators operand is true, which will return true. Okay, if A or B, either of them is true, it will return true to the assigned variable. Okay, so the third one is logical NOT. What it basically means is like if you specify not of true, it will return false. If you specify not of false, it will return true. It will just invert the value, either true or false. Okay, so now let's see bitwise operators. So as the name suggests, bitwise operator basically work on bits. So the first bitwise operator is AND operator. What it basically means that it returns 1 wherever there are both bits 1. Okay, so in this case we can see an example wherein we take the number 5 and 3 in place of A and B. So 5 in binary is 101 and 3 in binary is 011. Okay, so the result is 001. Why is that? So as you can see, the first bit is 0, 1 and 0, so it's 0, and 0 and 1, so it is 0, and both are 1 since it's 1. Okay, so this is logical actually bitwise AND operator, wherein it returns 1 in each bit position where both inputs have 1. Okay, so this is the AND operator. So the next is bitwise OR operator. Okay, so as you can see, we have this symbol which is actually for bitwise OR. We are taking the same example 5 or 3. What it does is it returns 1 in each bit position where at least one input has 1. Okay, so what it basically means is, if, as you can see up right here, if any of the bits have 1, it will return 1. Okay, in this case, the first in both sides have any of, like the first one have 1, so it is 1. So in the second bit position, the second one has 1, so it's 1, and in the third one both are 1, so it's 1. Okay, so this is how an OR operator works in bitwise. Okay, the third one is bitwise XOR operator. Okay, as you can see up right here, so what it basically returns is, it returns 1 in each bit position where inputs differ. Okay, what it means is, if the both bits are different from each other, like let's say it's 0 and 1 and 1 and 0, it will return 1. If both are same, like 0 and 0 or 1 and 1, it will return 0. Okay, so as you can see, we are taking the same example. 1 and 0, as you know, it will return 1, and 0 and 1, it will return 1, and both are 1 in the final bit position 3, so it returns 0. Okay, and in the last we will see some more details on this, like which actually combines and all. And the next operator is NOT operator. Okay, as you can see up right here, this is the symbol which we use for NOT operator, and this is not actually cover operator. Okay, as you can see, this one is actually a bitwise XOR. Okay, so as you might know, NOT operator just inverts the bits in their position. Okay, so if it is 1, it will become 0. If it is 0, it will become 1. Okay, so here in this case, if it's 1 0 1 inverted, 0 1 0. Okay, so the result will be 2. And the next operator is left shift operator. What it basically means is that it will shift 1 bits towards left. Okay, so in this case, we have taken the same example, we've taken a different example actually. 5 is left shifted to 1. Okay, so what it basically means is, 101 is binary representation of 5. We have left shifted 1 bits from it. So what happened is, 101, the first one gone left, so there is no 1 here. The 0 came left and 1 came to the left. And as you can see, first it was 101, then it became 0 1 0. Why? So the first bit like got left, so the 0 came to the left, and then 1 got left, it came to the second position. Since it takes 3 values, like 3 bits over there, we'll have to add a 0. Okay, so this is how a left shift operator works. Okay, and the final one is right shift operator. It's the same. Let's write it right shift. Okay, so let's say A is right shifted with 1. Okay, so in this case, let's do the same example of 5 right shifted with 1. So what will happen is, 101 is right shifted by 1 bits, which will result in 010. Okay, you got to know like the same result. Why is that? Because even if you shift the bits towards right once by 1 bits, what you will actually get is 1 comes to the right and 0 goes to the right as well. So it will be 010, which indeed is 2. Okay, so one thing you should actually notice in bitwise is, here we actually put the numbers, those converted into binaries. Okay, and then those binaries are operated based on the operator, and then those resultant binary is actually converted to decimal number. Okay, which you should remember, which we'll see in the further videos. Like there will be examples and we'll code our own smart contracts for different use cases. There you will know. Okay, so these are all the operators which you can use in Solidity. These you can use everywhere in Solidity within the functions. Okay, so this is all for today. I hope you got to know the bitwise operators, logical, comparison, and arithmetic operators in Solidity. So I'll meet you in the next video. Take care. Goodbye.